The What Works Clearinghouse Practice Guide on assisting students struggling with mathematics strongly recommends the use of number lines for math intervention. The number line is an especially powerful tool for building students' understanding of subtraction with fractions, a topic that is often challenging. The flexibility of the number line allows us to represent two models of subtraction: taking away and comparison. First, let's think about a context for subtraction as taking away. Here's a word problem. Isabel has a piece of ribbon that is 7/8 of a yard long. She cuts off a length of ribbon that is 3/4 of a yard to give to her friend. How long is the ribbon that Isabel has left? In this situation, Isabel is cutting off a piece of ribbon, which leaves her with a shorter piece. We can write this problem as 7/8 minus 3/4. Now let's represent this problem on the number line. First, I'll build 7/8 by lining up 7 1/8 tiles starting at 0. Then we can use the tiles to label tick marks. And we can see that these tiles make a length of 7/8 from 0. Next, we need to take away the quantity 3/4. But all the tiles on the number line are eighths. So how do I take away fourths? Well, I know that 2/8 is equivalent to 1/4 because they're the same length. So I can trade 6/8 for 3/4. Now I can take away 3/4 and I'm left with 1/8. So I've just modeled 7/8 minus 3/4 equals 1/8. Let's connect back to the word problem about Isabel's ribbon. We just used the tiles and the number line to find out that Isabel has 1/8 of a yard of ribbon left. We can also represent the subtraction problem without fraction tiles. Let's start again with a blank number line. So how should I partition the number line? Well, I know that eighths is a common denominator for 7/8 and 3/4. So I'll draw tick marks to make 8 equal parts between 0 and 1. Then I'll draw a point at 7/8 to represent the first number in my problem. From 7/8, I need to subtract or take away 3/4. Since I know that 3/4 is also equivalent to 6/8, I can rewrite the original equation as 7/8 minus 6/8. So to show taking away 6/8, I'm going to draw an arrow that is the length of 6/8. If I were adding 6/8, I would draw the arrow going to the right, because I'm increasing the amount. But since I'm subtracting, I'll go to the left towards 0 to show that the amount is decreasing. And then I'll put a point at the location where the arrow ends, which is 1/8. So you can see that we have a couple of different strategies for representing the takeaway model for subtraction on the number line. Now let's look at the comparison model of subtraction. Here's another word problem. Joel has a piece of string that is 5/6 of a yard long, and his brother Nick has a piece of string that is 1/3 of a yard long. How much longer is Joel's piece of string than Nick's piece of string? So we need to compare the length of the two strings, and we can represent this as the difference between 5/6 and 1/3. Let's start by using fraction tiles to compare the lengths. I'll put out 5/6 to represent Joel's string and 1/3 to represent Nick's string. Now I can see that 5/6 is longer than 1/3, but how much longer is it? This space here shows the difference between their lengths, and I can fill this space perfectly with 3 1/6 tiles. So this means that the difference between 5/6 and 1/3 is 3/6. And we can write that numerically as 5/6 minus 1/3 is equal to 3/6. We can also use the number line to represent the comparison model for subtraction. For this problem, I'll use a number line that's partitioned into sixths, because that's a common denominator for thirds and sixths. And I can rewrite my problem as 5/6 minus 2/6, using sixth as my common denominator. To compare these two fractions, I'll first need to represent them as points on the number line. To locate the 5/6, I'll start at 0 and draw an arrow to 5/6, and I'll put a point right there. Next, to show 1/3, I'll start at 0 and go a distance of 2/6. So how much further away from 0 is 5/6 as compared to 2/6? Well, I'll start at 2/6, and it takes me 1, 2, 3/6 to get to 5/6. So the difference between 5/6 and 2/6 is 3/6. Okay, let's recap how we used the strategies from the Works Clearinghouse Practice Guide. We demonstrated how the number line can be used to represent two models of subtraction, the takeaway model and the comparison model. For each model, we began by representing problems using fraction tiles, and then we progressed to using points, arrows, and labeling without any tiles. So you can see that the number line is a great visual representation of subtraction and a powerful tool for problem solving. We encourage you to try these approaches to engage your students in using number lines to model and solve problems.